Then, however, we cannot always think about the electron cloud shape by thinking about the hybrid orbital or like thinking about like electron configuration. So, but you don't have to worry about that because these days you can obtain the electron cloud shape by using the quantum chemical calculations, and some of the chemistry students have used Gaussian or Spartan or some other software. And what you have to do is you have to draw the molecular structure and then optimize the structure, and then the computer can give the information of the structure of the electron cloud. But keep in mind that basically you have to understand what are the principle and what kind of calculations are being made in the computer. So here's a brief explanation how to obtain the molecular orbital, meaning the electron cloud shape. So in the case of, again, ethylene case. So as you can see that molecular orbital psi is made of the various atomic orbitals. So please be aware that the difference between the atomic orbitals and the molecular orbitals, right? Literally, the atomic orbital are orbitals of the atoms. So meaning the 1s orbital, 2s orbital, 2p orbital, like the 2d orbitals like this. These can be calculated. These can be calculated by the quantum chemical calculations. And to obtain the molecular orbitals, we are thinking about the molecular orbital is an overlap of the atomic orbitals. So in this case, the 1s orbital of first hydrogen, second hydrogen, third hydrogen, and so on. And then, but she orbital, carbon has sp2 orbitals. In this case, 3 sp2 orbitals, and then also the pz orbitals. So what you are doing is, what you need to do is you have to assume the overlap of these atomic orbitals. And what you have to do, what you have to calculate is how much ratio of these atomic orbitals make a molecular orbitals. To do so, we are using the Schrodinger equations. So after solving the Schrodinger equations by minimizing the total energy of the molecules, you could obtain the percentage of each of the atomic orbitals contribute to the molecular orbital. So that's how you can do it. And however, if you are chemistry, from the chemistry, you have a chemical knowledge, and there's some simpler way to making a molecular orbital for thinking about the molecular structure. And for example, if you know the atomic orbital makes a bond, so two of the atomic orbital, for example, the fifth carbon and sixth carbon make a sigma bond using the sp2 orbitals. For sigma bond, you can think about the wave function. So molecular orbital is made of the sp2 orbital of fifth carbon and sp2 orbital of sixth carbon. And you can make a C1 and C2 are the unknown coefficients. And for pi bonds, you can make like a pz orbital of fifth carbon and pz orbital of sixth carbon, but coefficients are unknown. And but these coefficients can be obtained by solving the Schrodinger equation, so by minimizing the energy. And you can make, you can think like this. if you have C1 and C2 carbons, and then phi1 and phi2 atomic orbitals are making a bond with a sigma bond and psi, and then C1 and C2 are making a bond. And I don't show the calculation, but you can check the quantum chemistry textbook, and just by solving the Schrodinger equations, you can obtain the energy of the molecular orbitals. Actually, you can obtain the two energies are obtained like this. So one is alpha sp2 minus beta sigma, and then alpha sp2 plus beta sigma. And then for these energy case, you can obtain the wave function, so molecular orbital of the psi A and then psi B. And what you can know for these is you have fifth carbon C5 and C6. By making a bond, one of the molecular orbital energy is lower than the original. And again, if you take the energy axis, so this original value is called alpha sp2. So this is the energy of the sp2 orbital, atomic orbital energy. However, by overlapping these two bonds and to make a sigma bond, the energy of the molecular orbitals becomes lower and stabilized. That's why the two of the electrons are occupied in this state. And then how much this energy stabilization could happen, this value is called the overlap integral. So by overlapping the two of the atomic orbitals, overlapping to make the stabilization of energy. And on the other hand, there's another type of energy which is becomes higher, and so these two electrons are coming from each one of the carbons. This higher energy level is due to the overlapping with anti-phase. So I don't mention the phase things, but electrons are also, electron is kind of called a wave, electron wave. So which means electron property has some phase. So oscillation could have a phase. That's why the overlapping with the same phase can give the stabilization, but opposite phase case, the bond is unstabilized, and which is called anti-bonding orbitals. And if it's a stabilized case, it's called bonding orbitals. So this is how to make the energy level of the molecular orbital.